Cool. So I woke up before
Okay, we ready?
my alarm clock went off by a half an hour and it just went to bed. My knees are like purple.
Okay.
From Southern Devils last night.
I guess I haven't really looked at them.
Do you guys have any questions from your homework last night?
We said that we didn't you
14 through 17?
All of them?
I thought we were
Yeah.
going to work my class.
What?
I thought we were going to work on the
You
class.
said yesterday I studied all the way
Yes.
Yeah, you just decide you just like circle back out.
Yeah.
I could say session. Wait, Mr. Jubal, could we just like get back in our circle and work on it?
Yeah, we're just gonna finish them up real quick. I didn't think they were that hard. Were
I
they?
just don't.
Yeah,
That's
I always
like,
like
Yeah, I did like 2.
What haven't you learned?
I don't, it doesn't make sense.
Okay.
I just need to advice on like how to set it up.
Okay, that's
Or like
easy.
what to use, like when it asks which question.
Okay, that's an easy thing to teach you guys, and it'll be a handy skill from now until the end of time. As far as chemistry goes. Okay,
There's a hand in my foot.
let's see. I did number 12 for most of you on the board. You're in study hall. Is everybody in here in study hall?
Yeah.
Number 13, carbon monoxide burns in oxygen and forms carbon dioxide. Okay, so before we can do anything, we have to write the formula. And that formula is CO plus CO2 yields.
And O2.
Yes, I know, I was going to say it yields carbon dioxide, so I'm in trouble here. Okay, and then we got to figure out the correct coefficients. So, we have 3 oxygens on one side, 2 on the other. That's not going to work, so what's the formula? 2 carbon dioxide? So 2, 4, 4. Okay, 4, 2, 2, 4. Okay, that works, right? So now our ratio is 2 to 1 to 2, right? Okay, what is our given? Oh, we didn't get that far. 13. How many liters of carbon dioxide are produced when 25 liters of carbon monoxide burns? Okay, so we always start our problem with our given, okay? So we have 25 liters of carbon monoxide, right? We're going to burn that. So X, welcome, X equals, whatever we're trying to figure out, oxygen? No, carbon dioxide. Okay, well actually then it should be Y. This is going to be X, and this will be Y. Okay, this is our given. Okay, so Y equals 25 liters of carbon dioxide times, okay, so we're going to do the mole ratio. And we have carbon monoxide, sorry. So we want that one on the bottom, simply so we can cross it out. That's all it is from here on out. You do it just to figure out, you use the units, and you cross them out till you end up with the units you want. That is how you know which numbers to use. Does that make sense? That's how I do it. That's how I've always done it. So I don't want carbon monoxide anymore. I want carbon dioxide. So I'm going to put the ratio of 2 moles of carbon monoxide to 2 moles of carbon dioxide. And cross out carbon monoxide and cross out moles. I'm going to end up with liters of carbon dioxide. And it's going to be 2 crosses out, so it's going to be 25 liters of carbon dioxide. Okay? Make sense? And the second part of the problem, how many liters of oxygen are required? So we just do X now. Same thing, 25 liters. Oh, I'm sorry, we're still going to use carbon monoxide. Okay, so now oxygen is 1 mole O2, 2 moles CO. Cross out the COs, cross out the moles, divide 25 by 2. So answer's what? Answer is 12.5 liters of oxygen. Okay. All right, so that is the process, and I think every one of these problems you do exactly that over and over again until we get to the last problem, number 17, which is what I was going to teach you today. So I should take care of it. Okay, so we'll set up the rest of the problems, but we just won't carry them out, okay? Is that good? All right, the next one, acetylene gas burns in oxygen and forms carbon dioxide and water vapor. So acetylene gas is C2, H2 plus oxygen, right? Burns in oxygen, forms carbon dioxide and water. All right, so first thing we got to figure out our formula. Anybody have that? You know how to do that, right? You learned that before. Okay. Anybody have the formula? Anybody not know how to figure it out? Somebody should give me the answer.
I think it's C2H2 plus 2O2 use CO2 plus 2H2O.
Okay, so let's see. So we have two C's, two C's, two H's,
Oh, wait, never mind. Yeah, I can't.
four H's.
Yeah. Get the carbons to balance it.
How do you?
Yeah, I can't get the carbons to balance. Yeah.
Okay. All right, so
I thought
you need two of these. So if you put a 2 there, you have 4 oxygens.
you need a 5 oxygen. Because you 2 over there. And
Right, so that's not going to work.
Yeah.
That's where I was going. So that doesn't work. So we're going to take those out. And so now, if we have 5 oxygens, so then what we have to do, we need an even number. So we just double that. So let's try 10 here, which gives us, and so we could at least need 4 here. Is that right? 4 times 2 is 8. 4 times 2 is 8. 4 and 5. No, 4. That's not right. I know this is 10. I did all these problems and left them at home. Okay, so C2, 4 times 2 is 8. 4 times 2 is 8. 4, 8. I'll put a 4 here. Put a 4. So this is 8. 4 is 12. That would be 12. Does that work? That works, right? This without this. This is 6. Does that work? 4 C's, that's 8 C's. That doesn't work. 8, 2, 4 times 2.
10 on 2 does work.
What?
I think the 10 on 2 does work.
Okay. All right, so if that's 10, then that's 4, that's 8. This has to be 2. This has to be, it doesn't work, does it?
Oh, I think I got
What?
the 2C2H2 plus 5O2 yields 4CO2 plus 2H.
2, 2, 4.
If instead of the 10,
Yeah. 2 times 4, no, it's 10. 2 times 4.
No.
So this works. That's 4, that's 4, that's 4, that's 4, that's 10, that's 8 plus 2, that's 10. That works.
Wait, but isn't that 20?
Yeah, that's
It was
20.
at 10 times.
Oh, I'm sorry, this is supposed to be 5. There we go. Okay, so we got that. Okay, the question then is, how many liters of oxygen are needed to burn 15 liters of acetylene? So, 15 liters of C2H2. And then we want to know oxygen. Oh, our ratios are 2, 5 to 4. So it's 5 moles O2 over 2 moles C2H2. And that'll give us liters of oxygen. Okay? And then you can just go from there.
I was confused on how to set up B. Let's ask for like how many moles.
How many liters of carbon dioxide are formed in C? How many moles of water are produced? Is that what you're asking? The C one?
Oh, yeah, I guess I did see C, I thought it was G, but yeah.
Okay. Water is going to be a liquid at STP, and so we can't do any problems with it as a gas. But remember, this ratio is a mole ratio, a volume ratio. It's 2 moles to 5 moles to 4 moles to 2 moles. So it's just 2. So how many moles of water? That's the only way we can find out about water is how many moles. They can't ask how many liters or anything else, just how many moles. So the answer is 2.
That was C.
That was C. Do you want me to do part B? Part B is just going to be figuring out the carbon dioxide, so you just substitute 4 here, and then that's your answer. Okay. Part B is just asking us for this one instead of this one. And so we'll just set it up with 4 moles of CO2. So you just,
So,
it's exactly the same problem, only instead of 5 moles of O2, it's 4 moles of CO2. Okay, 15, C2H6. Plus O2 yields CO2 and water vapor. Okay, so 3 on one side, 2 on the other. So we can try 3. Oh, 6 of those. 3. 7. 7 over here. anybody get this? Did you?
I just did now.
Oh.
I have different books, but I've never done it. Instead of 7, 4, and 6, I had 3, 2, 3. I think I must have done 7.
Yeah, that's what I had first, but three of these is gonna be 6. 6, and then you have 3, 5. Those. You can't have an odd number, if you have O2. Okay.
How can, if you have 7 or 2s on one side, you have to have 7 on the other, right?
I have 7 on this side, I have 2 times 7 is 14.
Oh, well, 7, gotcha.
So I've got 14 on the other side. Okay, so, somebody else tell me how to do the rest of the problem. What's the next step?
Start with given of liters,
Okay. 20 liters of
essence,
C2H6, okay, times,
1 CO2 over 2 C2H6,
4 moles, CO2 over 2 moles, C2H6, cross out. Liters CO2. Okay. How many moles of water are formed? Correct. Skylar has it. Anybody else have it? 6, okay. And it's just this number sitting right there. Okay, 16. This one's a little more difficult, and I really don't think I taught you that part yet. It's in the next section, so. We are going to do that now. So we'll start with. So that's good enough for your homework. You don't have to do 17. And actually, it's not really homework because we did it all in class. So never mind. All right.
we don't do 16.
Did I do 16? I just did 16 things. That's
You did 15.
oh, I didn't do 16. Oh, that was the air one. I'm going to teach you that now.
So we'll do 16, but we don't do 17.
All right, you're not going to turn it in, so you can
Oh.
do 16 if you want. You can do 17 if you want. Or you can do either, I think. So we're going to do the problem 16. We're going to answer that right now. So if we assume air to be 20.9% oxygen by volume, how many liters of air must enter a carburetor to complete the combustion of 30 liters of octane vapor? Octane has this formula, C8H18. Its complete combustion produces carbon dioxide and water. So whenever you hear the word combustion, that means O2. So you have to add oxygen, and you get 16 CO2 plus 18 H2O, and it's a liquid. Okay. So the ratio is 2 moles. Whoops. This is a 25, sorry. 25 to 16. Okay. So it gives us, it says 30 liters of octane vapor, so we have 30 liters of C8H18 times the mole ratio of 25 moles of 2, which is what we want to know, over 2 moles of C8H18, and that equals 15 times 25, which equals 375 liters of oxygen. Okay, that's how much oxygen we need, but the question asks us how much air do we need. Oxygen is 20.9% of air, and so the air required is going to be equal to 375 liters of oxygen times 100% over 20.9%, 20.9%. Percents cross out, and it equals 1790 liters. And so then that's how much air we need. Okay. This is 29% of oxygen. So that crosses out. Okay. Okay, and this is a gas volume. You know, a gas, we want this volume of gas gives us this volume of gas. So everything is measured. So whatever, as long as the pressure and temperature are the same, we can do these problems. And so this is measured at the temperature that this happens. We are measuring this, and so it all works as long as the temperature is kept the same, the pressure is kept the same. Okay. When we go from volume to mass problems, then we have to work at standard temperature and pressure because they don't mix. Okay. So we have to bring everything down to standard temperature and pressure, or we have to change the information they give us to standard temperature and pressure to be able to do those kinds of problems, which is the next section. So, okay. And because of this, water is a liquid in this particular instance at that temperature and pressure, so we can't even consider water as part of our problem. Okay. If we want to do water, we got to do a whole nother kind of thing. So, all right. So we're going to do gas. We'll do the volume problems. I mean the mass volume problem. So let's say we have, so we're going to look at the volume of gas and the mass of a solid. Okay? So when you read the problem, you have to understand that we're looking at a solid and a gas now, not a gas and a gas. And when you read the problem, you have to decide whether you're going to do it that way that we've just finished doing, or if you need to use this kind of formula. So we want to know how many grams of calcium carbonate, that's calcium carbonate, must be decomposed to produce 5 liters of carbon dioxide at standard temperature and pressure. So this goes to CO2. Sorry, I'm going to do the solid first. CaO, which is a solid, plus decompose that to produce 5 liters of carbon dioxide. So we have 1 mole of this, gives us 1 mole of that, gives us 1 mole of that. We know that 1 mole of calcium carbonate equals about 100 grams. Okay. And again, that's 44 plus 12 plus 3 times 16 is 100. Okay, 1 mole of CO2 equals 22.4 liters. And we know that this is, this is 5 liters. That's what we want. This would be X over there. Okay, the reason we can use 22.4 liters is because we're working at STP. So this is a standard temperature and pressure problem. So that's why we're going to use 22.4 liters instead of grams per mole. Okay, so we'll take, excuse me, 5 liters of CO2 times 1 mole has 22.4 liters in it, no matter what we're talking about. So that's a constant, so we're just saying that. And so this is going to give us moles, number of moles we need. So it's just going to be 5 over 22.4 moles of CO2. Okay? Okay, I'm gonna finish this up, and whether you get it or not, this is the answer. 5 liters CO2 times mole over 22.4 times 1 mole of CaCO3 over 1 mole CO2 times 100 grams per mole equals 22.3 grams calcium carbonate. So that's the answer.
Oh, sorry.
There you go. All right, have a good day. See you guys later.
Thank you.
You're welcome.
Thank you.
We have just one little thing, we're done with gases.
But they're all like bright colors.
Oh yes, turn that off.
Laura,